what you put into your body, and know that all these types of things can affect your blood pH as well. All right, let's walk through some scenarios. These types of questions are questions that I typically like to ask in different ways on exam 4 to make sure you understand the blood buffer system. I think that's a very appropriate thing for you guys to walk away from this class knowing the chemistry of it. So we're going to walk through this scenario. What happens, the first one is, what happens to blood pH if you hyperventilate? Okay. Well, if we are hyperventilating, hyper means we're breathing a lot, too much, maybe, too fast, really fast. And so we're increasing, and I like to walk these out with abbreviations. So if you have a question about what any of these abbreviations mean, or you didn't catch it from the video, shoot me an email. If we are hyperventilating, we're increasing our rate of respiration. So I'm going to abbreviate respiration with an R. We're increasing the rate of respiration. From the viewpoint of your blood and your body, if we're increasing respiration, how is that affecting the amount of CO2 that is in our body? How is increased respiration affecting the amount of CO2 in our body? Well, if we're increasing respiration, we're exhaling a lot of CO2, okay? Exhaling, we could even say elevated amounts of CO2. So if that happens in our body, the concentration of CO2, OC2, concentration of CO2 is going to go down. Remember, this is all from the viewpoint of our blood or of our body. So if we increase respiration, we decrease the concentration of CO2 in the body. Now, if we have a lower concentration of CO2, here CO2 is a reactant, what does Le Chatelier's principle say about a shift in equilibrium here? If we decrease the amount of a reactant we have, equilibrium would shift to the left to replace the thing that has been taken away. So equilibrium shifts left, this way. If equilibrium shifts left, is shifting left, what is going to happen to bicarb and H+? What are the concentrations of these things going to do in the blood? Well, to shift left, we have to bring bicarb and H+ together. We have to react them and make more H2CO3 and make more water and CO2. So the concentrations of HCO3 minus and the concentration of H+, they go down. We're going to use those up to make more CO2 because maybe we're exhaling or we're breathing out too much for hyperventilating. All right, now the question is, what happens to blood pH? How does this affect pH? Well, if we're decreasing the concentration of H+ in our blood, you guys remember the two relationships I said you need to memorize for exam 4 about pH and concentration of H+? If we're losing H+, we're increasing pH, okay, of our blood. So that answers this first question, this first scenario. So we could end up in a state of respiratory alkalosis if we're not careful. Could, okay. Now let's look at the second one. What happens to your blood pH if you hypoventilate? So hypoventilate is the opposite of hyperventilate, which means we are not breathing fast enough. We're slowing down our breathing, okay? So if we're slowing down our breathing, we are not exhaling very much CO2. So what is that going to do to the amount of CO2 in our body? If we're not exhaling very much CO2, the concentration of CO2 in our body, in our blood, is going to go up. We're keeping it in our blood because we're not getting rid of it as fast, as quickly. So if we have, let me erase everything that I drew up here. if we're increasing the amount of CO2 in our blood, how is that going to affect equilibrium? Well, Le Chatelier's principle says if we increase the concentration of a reactant, equilibrium shifts towards products. So equilibrium is going to shift to the right. And how is that going to affect the concentrations of HCO3 and H+? Well, we're going to make more of it. So the concentration of bicarb and H+ are both going to go up when equilibrium shifts to the right. And this is amount of H+ in our blood. How does that affect blood pH? That's the question. Well, if we increase the amount of H+, we're decreasing pH. We're becoming more acidic. So this could lead to respiratory acidosis if we had really prolonged hypoventilation. Okay? That's where it could lead to. All right. Next scenario. Let's look down here. What happens to your breathing rate if your kidneys can't store HCO3? We kind of started to walk through this in a slide earlier, but that's why I didn't want to go through it super well because I knew we were going to get to it down here. What happens to your so the question is not what happens to your blood pH, but what happens to your breathing rate. So you guys maybe don't even realize our kidneys and all this are and our lungs, everything is connected. So how would our breathing rate respond if our kidneys can no longer store bicarb? All right, so kidney failure, what that's going to do to the amount of bicarb in our blood. So look at these arrows right here. If we're storing bicarb, that means we're pulling it out of the blood into the kidneys. But we can't do that. So we can't do this right now. So what that means is we're going to get a buildup of HCO3 in the blood because maybe we need to store it and we just can't because our kidneys are not working. So what's going to happen is you're going to have a buildup. We're going to increase the concentration of HCO3 minus in the blood. Notice we have not said that we increased the amount of H+. We have only increased the amount of bicarb. But if we do that, what does Le Chatelier's principle say? If you increase the concentration of any product, equilibrium will shift towards the reactants. So equilibrium shifts left. Now to shift left, you have to take one molecule of bicarb and react it with one molecule of H+. And then it'll shift left. But we're not asking about blood pH here, so we actually don't need to go down that road. I just wanted to point that out. But when these two things react, we're going to shift left to make more of our reactants here. So how is that going to affect the amount of CO2? We don't care really how it affects the amount of water because that's not going to affect our breathing. But the amount of CO2 will affect our breathing. If we shift left, the concentration of CO2 in our blood, why do I always write O first? I think because my hand says I wrote a bracket and a bracket looks like a C. It's CO2. Okay, so we've increased the amount of CO2 in our blood. How will that affect our breathing? Well, if we have too much CO2 in our body is going to try to level that out. We don't want too much CO2. We want to keep an even amount of CO2. And if we have too much, then our respiration will increase. Increase respiration to exhale the levels of CO2 that are potentially unhealthy. Okay, so that's how our breathing rate would be affected. We would increase respiration. Let's look at the last scenario. What happens to your breathing rate here? Not blood pH, but what happens to breathing rate if you accidentally inject yourself with NaOH? Oh, great idea. If we inject ourselves with NaOH, which is a strong base, what the heck would happen to our breathing rate? Okay, so we don't have NaOH. If we look at I'm going to kind of erase all my drawings. if we take a clean look at this blood buffer system, we don't have NaOH anywhere in here. So what the heck? How do we know how this is going to respond? Well, you need to know what a strong base would do. Would a strong base react with any of these components in our, and in fact, we're not even going to say H2CO3. You're going to pretend as though this middle guy, H2CO3, is not here. So would it react with any of the things I've underlined? Would it react with CO2? Would it react with water? Would it react with HCO3 minus? Would it react with H plus? Some of you might think, well, it would react with water. We could draw a reaction for that, and we could. But is there anything that kind of sticks out that it would want to react with most? Like if it had the choice. NaOH is a strong base. They like to react with strong acids. They neutralize each other very well. Is there anything in our reaction that kind of sticks out? And you should say yes. It should be H plus here. H plus is just waiting for a base to come neutralize it. Okay? So when NaOH sees H plus in the blood, it would definitely react with H plus. And if that happens, what would we get? Well, we would get sodium ions. Are those bad for our blood? No. And we would get water, which is neutral. We have water in our blood. So these things are very docile to our blood, not going to affect us. But this is what would happen. So if NaOH is going to react with H plus, how is that going to affect the concentration of H plus in our blood? Okay, so essentially what's happening, I'm going to zoom in. We injected ourselves with NaOH. It's going to come along, scoop this guy up, and make water and sodium. So the amount of CO or H plus in our blood is going to go down because we're removing it. We're neutralizing it with OH minus. So H plus in our blood goes down. Okay, so if we decrease the amount or the concentration of a product, Le Chatelier's principle says that equilibrium will shift in a direction to replace the thing we take away. So equilibrium will shift right to replace H plus. We're taking H plus away. It's going to shift right to make more H plus. Okay, when the equation shifts this way, we're going to make more of our products. So that will restore the concentration of H plus, but how is that going to affect our breathing? Well, we don't care how it affects water, we care how it affects CO2. If we shift right, the concentration of CO2, we've not added any more CO2, we just have regular amounts in our body. So if we're having to use it up to make more H plus because we are removing H plus, then the concentration of CO2 ultimately is dropping. And how would our breathing respond to try to correct for that? If we have very little CO2 or too low of amounts of carbon dioxide in our blood, how would our breathing respond? Would we want to breathe faster and exhale even more CO2, or would we want to slow down our breathing? Okay, if we slow down our breathing, slow down respiration, then we would help to build up the amounts of CO2 in our blood, because we're not also depleting CO2 levels by breathing even more out. So we'd want to slow down our breathing, decrease respiration to try to account for ultimately the loss of H plus. Okay, so if we inject ourselves with NaOH, we're going to decrease the amount of H plus in our blood. Equilibrium shifts to the right. We drop CO2 levels. We could slow down our breathing to help correct for that. Okay. Feel free to make up other scenarios. How would your breathing rate be affected if you injected yourself with acid, HCl, or whatever? Think through those things as well. Like I said, I definitely like to ask these questions because not only does it make sure you understand your blood buffer system and how things